All right, I guess it's time to start. Welcome back to everybody. I hope you all had a good break. This is Calc 2. I hope you're ready for more calculus. My name is Professor Stecker. That's how you say it. It's like German. Stecker. I am glad to be here with all of you. I hope you all had a good break. I had a pretty good break. Now I'm back to work. You're all back to school. It's good to be here. So I thought today I want to go over the syllabus a little bit, and then I think we'll have enough time to get down to some business. Yeah, let's all check out the syllabus here. If you see me checking out my phone, it's because I have this little clock, because I can't really see the clock over there. That's what I'm looking at if I'm looking at my phone. All right, so you can see on here, this is Math 1172, and I'm hoping that most of you are just coming like straight out of Calc 1, the 1171. You don't have to be, but that's kind of the intention for this class of Calc 2. There are other flavors of calculus here at Fairfield, just in case you're just joining us. There is also, this is the 1171 and 1172. This is the 1172. That's the number for this class. There's also 1121 and 1122, which is called applied calculus. And those ones are typically taken by like people in the business school, and the nursing students take that one, and so on. If you think that maybe you shouldn't be in this one and you should be in a different calculus class instead, please let me know. But if you were in the 1171, which is called Calculus 1, then this is the next one. So hopefully we're all in the right place. If you're concerned about that, let me know, and I'd be happy to advise you about which class you ought to be in. All right, anyway, on here you can see my email address there. That's probably the best way to get in touch with me. My office phone number is there. Nobody ever calls me in my office. You can call me if you want to. You won't, though. That's fine too. Emails is usually the best way to get me. My office is in Banno GR17, which is kind of like the basement of this building. Actually, there's stairs right here. If you go all the way down those stairs, you'll be on the ground level. The ground level doesn't exist on the other half of the building, like closer to the Tully. You can't go all the way down, but here you can. Anyway, my office is down there. It's a little hard to find if you've never been down there. My office hours, you can see written there. These are times when I will definitely be available. This includes right before class every time, so it would be convenient if you got questions about homework or whatever. Come on by. If those times are not good for you, then let me know and we can work something else out. You can come down to my office, or you can come on Zoom if that's more convenient for you for whatever reason. Usually, if you want to come on Zoom, go to this link, and I may not be there if you show up. Sometimes, like during my office hours, I usually just like turn on the Zoom so that I'll be ready for you if you show up. Sometimes I forget. If you show up and I'm not there, I will get a notification, and just like wait a few seconds and I should appear soon enough. All right. You can see a link for the class website, and that's what you will get if you scan this QR code. You will want to visit there every so often. At least this is where I'm going to post the homework assignments from week to week. So at least for that, you're going to want to go there and get the assignments. You can get there through Blackboard also. Although I don't really use Blackboard all that much. This is like my own website that I made. So, but if you go to Blackboard, you'll see a link to get to here. Go to there. That's where the good stuff is. The textbook is the Stewart book, which you can get on paper, or you can get probably most of you have the electronic version, which will be fine. I'm not going to ask you to like sit down and read the textbook. It'll be mostly just for the homework assignments. All right, great. Here's the final exam date there, Tuesday, May 5th, 3 to 6 p.m. Put it in your calendars or something. Can we just go through this? This is not all that fascinating, but the course content, basically this class is about the integral and sequences and series. Sort of the general structure is Calc 1 is mostly about limits and the derivative, and you did sort of like an introduction to the integral in Calc 1, I hope, and then Calc 2 is kind of the first maybe half or a little bit more than half is all more about the integral, and then the rest is about sequences and series. So that's where we're going. You will feel like this is very, I mean, it ought to be like very similar in flavor to your Calc 1 class. That's my goal at least, although none of you were in my Calc 1 class, but that's the idea. All right, the homework. Let's just go through the business here. There's going to be homework due every Wednesday, not including tomorrow, but I think we're going to do enough so that we can have a homework assignment due next week. Every Wednesday evening at 11:59 p.m. You're not going to give me the homework in class. You're going to send it in online, and we'll talk a little bit about that. I use this site called Gradescope, which you should have got an email from them this morning when I signed you all up for it. So we will talk about that a little bit more later. But anyway, the idea is you are going to see the assignments on the class website if you follow that link there. Do the homeworks, send them in every Wednesday. That's how it goes. The sort of the rhythm is after class on Friday, I will post the assignment that covers everything that we did that week, Tuesday, Wednesday, Friday. And then that assignment you will have the weekend plus until Wednesday to do it. Right? Any thoughts about that? And the homeworks are going to be, like a usual math homework. You get the questions out of the books and you write the answers. All right? Great. Let's turn the page. Okay, this is a little complicated. Mastery-based assessment. This is weird, so pay attention, is what it says. Most of your grade is based on topic mastery. This is weird, so pay attention. The other paper that you got is this big list of 25 different individual objectives for the course. So your job this semester is to learn how to do these 25 things. It's roughly one per class meeting, although I think we have something like a little over 30 class meetings, so it's not exactly that, but this is your job for the semester, is you have to learn how to do each of these 25 things. And as we go throughout the semester, you are going to, by taking quizzes and tests or whatever, you are going to get points for each of these 25 things, and you will check them off on your list. So like this piece of paper that I gave you, you should keep this specific piece of paper for the rest of the semester. If you lose it or whatever, I'll give you another one. I posted it at this link anyway if you ever need a new one. But anyway, this is your mastery checklist, and your job as we go through the whole semester is to check off all of these things. And the goal is, by the end of the semester, you have them all checked off, and then you get an A for the course. That's the idea, all right? This is a little different from usual kind of math tests and grades. I don't know if you've done a class like this, but the idea behind this style of grading is when you learn math, this is true for me at least. When I learn math, usually I learn something and then I do it wrong a bunch of times, and then eventually I figure it out and I do it right, okay? Unfortunately, in a math class, if you're like taking tests every so often and you get it wrong twice and then you get it right the third time, your average is still screwed because you got it wrong the first 2 times, all right? This is not how the grading in this class works though. So the idea is you will get several chances to get these questions right. Once you get it right, you check it off of your list and you got it right. If you got it wrong earlier in the semester or whatever, this doesn't affect your grade at all, as long as you eventually get it right. This is the idea. I hope that this is making some kind of sense. So you will see on the each thing you can get 1, 2, or 3 points, and you will have multiple attempts at each of these things. If you get 3 points the first time around, that's great, and you check that thing off and you don't have to do it again. If you get only, if you get 1 point the first time around, you can keep your point, but you can also try again to improve to 2 or 3 points later on. All right? This is the basic idea. Okay, so the details, let's see here. Yeah, you have your big list, and I am going to, this is kind of a nightmare to keep track of, but I have a giant spreadsheet where I keep track of every single question for all of you, how many points you have for each one. It says, all right, I'm looking in the top paragraph there. Your grade is based on topic mastery, all right? You have a big checklist. Students demonstrate their mastery of each objective by correctly answering questions on quizzes and exams, each of which is clearly labeled as assessing one of the objectives. And it says there's no penalty if you get it incorrect, but that objective will remain unmastered. You can try again to master that objective on another quiz or whatever, all right? So the idea is we have homework due on Wednesday, right? Typically we're going to do about one of these topics per day in class. That means each week we'll do about 3 of them. And the following week, so the homework will be due on Wednesday, not the following week. The next class meeting is a Friday, and we will have a quiz on the stuff that was on the homework on Wednesday. And on the quiz on Friday, that's your chance to get these points. All right, so after one homework assignment, which maybe one homework assignment has 2 topics on it, those 2 topics will appear on the quiz on Friday. For each of those, you can get 1, 2, or 3 points. If you get 3 points, then you're done with that topic and you don't have to do it anymore. If you only get 1 or 2 points, you can try that topic again to increase your score. Everybody understand what I'm saying here? I know this is complicated. I think it's a good system though. So that's what it says under the quizzes and mastery opportunities. Each Friday there's a quiz at the beginning of class. This doesn't take up the whole class. It's just like the first 10 minutes or so. The quiz usually has 2 or 3 questions on it, 1 from each of the topics. And we'll do the quiz, you hand it in, and then we'll just go on with the rest of class as usual. All right? If you miss a quiz, you got to let me know ahead of time and we'll work something out. But don't just not show up to a quiz. It says students who need to miss a quiz should contact the professor ahead of time to make arrangements. If you simply do not show up to a quiz without letting me know ahead of time, you probably will not be allowed to retake it. That means I suppose you get a 0, although getting a 0 is not such a disaster because you'll have more chances to try those. You'll just miss those questions. You'll miss that opportunity to get points on those items. All right? It says after that, once every 2 weeks, students can make an appointment with the professor during office hours to attempt an old question. So if you don't get full credit on one of these questions when you see it on the quiz, you can send me an email or talk to me after class or whatever. Say, I want to come in and try, number 5 again. And then you'll come to my office. I'll give you another number 5, and you can see how it goes that time, all right? And your new grade will just replace the old grade. If you only got 1 point the first time, but you get 3 points, your new grade is 3 points. You don't average them or anything like that, all right? It replaces the old grade, but I'm not going to reduce your score. Like if you got 2 the first time and then 1 the next time, I'll let you keep the 2. So try them again. All right? Any questions about this? I know this is weird, but I hope that this sounds good to you. It does mean we are going to have a quiz every week, which maybe sounds stressful. Although I hope if you're understanding the system correctly, actually in this system, you kind of want, it'd be better if you had a quiz every day, right? Because a quiz is just another chance to get more points. So actually having more quizzes is good for you. I sound like an abuser or something, but trust me, this is good for you, even if it doesn't seem like fun. All right, it says at the end of the quizzes bit there, students will not use calculators during the quizzes. This is just because I don't want you writing all the answers in your calculator ahead of time. I know some people have fancy calculators, and I just don't want to get into all that. So all of our you'll see how this goes as we go, but I'm not going to ask you to do problems which involve multiplying big numbers together on the quizzes or the tests. On the homeworks, I will expect you to use your calculator, but for the stuff that we do in class, I want no calculators, and all the numbers will be easy to manage. All right. All right, we also have deal breakers. So this is kind of bad news, I suppose, from your point of view. It says the most fundamental topics on the list are marked with stars. You can see some of them have stars next to them. Those are the deal breakers, and you must get at least 2 out of 3 points on all of the deal breakers, or else you will not pass the class. So remember, we have you have chances to reattempt these questions. I said you could retry one every 2 weeks. Although if you're really desperate about the deal breakers, I'll let you try them more than once every 2 weeks. You will straight up get an F if you don't have at least 2 points on all of the deal breaker questions. All right. Now, I say this like a threat. This, I suppose, is like a threat. More realistically speaking, none of you will get an F because of this. You will just be like coming to my office over and over again trying these questions until you eventually get them. Those are the ones with the stars. Those are, like, in my opinion, the most important ones. You have to get 2 out of 3 of those before the end of the semester. All right. One last thing to say, and then I'll see if everybody is understanding. The catch-up exams. So there's going to be 2 catch-up exams, which you can see it says on March 20 and April 29th. That's the last day of class. Those exams those are basically like giant quizzes. They will take up the entire class period, and each of those exams will have 1 question from every topic on the list. If you have already gotten full credit on that, on that topic, you don't have to do it because you already have maximum points. But this is, I call it a catch-up exam because this is yet another chance for you to sort of fill in the ones that you didn't get the first time around. So all of these questions will have appeared on a quiz already, but the big test is just like one more time to try them all out, all right? To catch up on the list. All right. There's also a final exam. The final exam is more like just a straight up ordinary test. So the final exam will be all new questions. You will have to do all of them. On our like the catch-up tests, you don't have to do all the questions, only the ones that you don't have points on. But the final exam will be a more traditional exam. It will be cumulative, and you have to answer all the questions. Of course, I'll say a lot more about that when it gets closer. All right, any questions about that? I know this is complicated and confusing, but I have found, I think that this is a more appropriate way to judge your performance, because like I am, like, completely honestly, I really don't feel bad about you if you do something wrong over and over again and then eventually figure it out. Like, to me, that's good, and that's how it should be. And so I want to make the grading system something which resembles that. All right. Of course, if you do get it right the first time around, then that's great. You don't have to do it again. But I want to allow you to make mistakes, at least temporarily. All right. Excellent. That's all the big business. So one last thing I want to say, and I think we can get down to some calculus, but last thing I want to talk about is the online submission. So we are going to use, this is a website called Gradescope.com. And I don't know if you've used Gradescope for your other classes before. I like this system. You are going to submit your homeworks this way. And the way it works is you are just going to write your answers on ordinary paper the way that you typically would write your math homework. You don't have to type anything, which is a real pain when you're doing math. Write your homework answers on ordinary paper. Then you take a picture of them with your phone and submit the pictures on Gradescope. This is how the system works. So what I would like to do, just to get us going, I want to make sure that everybody is able to use Gradescope well and everything is working. You should have gotten an email this morning with instructions about how to log in. What I want for you all to do is, if you log in there, you are going to see a dummy assignment. Your job, you should do this on your phone and on paper. I see a lot of people with computers. You can do it on your computer, but remember I said you're going to write your answers on paper and then send in a picture with your phone. This is a lot easier to just do everything through your phone. There is a Gradescope app that you can get and try, but actually I've never used the app, and I think it works just fine to just go to the Gradescope website. So get your phone, visit there. Your job is to write, this is just a stupid assignment. I don't really care what you write, but let's say write something interesting about yourself. You're going to write this on a real piece of paper and then send it in to Gradescope. Now, I'm just now realizing I forgot to turn on the first assignment. So while you are writing down something interesting about yourself, and find that email that tells you how to log in. Sorry, I'm gonna, if you will give me a moment, I'm gonna turn on the first assignment here. All right, if you log into Gradescope, you should see the first assignment there. So I'm gonna walk around just to make sure everybody is doing okay. Like I said, the point here is just I want to make sure that everyone's able to log in and do it just before we have like a real assignment, which will be next week. My screen back on. Get anywhere? You guys doing okay? Getting in there? Is it working? Yeah. You guys doing all right?
Get started.
Doing okay? You okay? Yeah.
Very good. Okay. Yeah. All right. Then we'll work it out.
You guys doing all right?
Okay. What's on? Good work?
Yep. Yes. You know what's up. All set? All right, great. I'll give you a few more minutes. Let me know if you have problems. If you have like serious problems, we may have to work it out later, but I hope that everything's going okay for everybody. You're just as good as ever.
Thank you right there.
Doing all right? Usually you're going to send out signatures because you'll have which problem's on which page. All right, folks seem to be doing fine. I think we can get it moving along here. If you ever have real issues with Gradescope, let me know. We need to get it all figured out, I suppose, before next Wednesday, which is when our first real assignment is due. But as I was going around, it seemed like people are doing okay. Let me know if everything, if anything doesn't go well. We can discuss it. All right, I think just one, if you go to the last page on the syllabus, I just wanted to talk about the grading breakdown you can see right there. So the big checklist is where most of your grade comes from. That's 60% of your grade. And that will be based just on like an average of how many points you got. You know, like I said, ideally you will end up with 3 points on everything, although practically speaking, most people don't actually get full credit on everything. You will get some amount of, 2s and 3s or whatever, and I'll just take the average of everything, and that's your mastery score. And then we have the homeworks, and the final exam is in its own category because the final exam is not based on this checklist. It's like its own thing. So that's 15% of the course. All right. A little thing here about attendance. So you will notice attendance is not part of your grade. So there's no like grade penalty for missing class. If you do miss class though, you are responsible on your own for, making, for sort of like dealing with that. I don't mean I'm not going to help you catch up, but I just mean like it's on you to like initiate with me. For example, if you miss a quiz, I'm not going to like try and call your mom and say, hey, you missed a quiz. Like, you tell me that you missed a quiz and we'll work it out. But I'm not going to sort of chase after you if you're just missing class for no good reason. There's no penalty per se, but that's, I will leave it up to you to initiate that kind of discussions. All right? Any thoughts about any of that? I think this is all I wanted to say about the course in general before we get moving. All right, I am going to do everything on these screens here. I hope that you can see them all right, and I hope that's okay with you. I like to do this because I am, maybe you noticed when I started up, I am recording like video. I don't have cameras or anything, but just like video of me writing and also the, what I'm saying. It's going to be fascinating. But I'm going to, after class every time, I'm going to record them and put them on YouTube. So please, like and subscribe. You can go there. This is just for like if you miss class or whatever. This is an easy way for you to catch up. And also, if you're trying to do the homework and you're looking at your notes and it doesn't make sense or whatever, you can always tune back in. So I hope that that's helpful. I am also going to take what I'm writing here and export it as a PDF and post that. Just in case, like if you don't want to watch the whole video, but you just want to see the notes, you can do that too. So these are just things that I hope are helpful. All of these things will be posted at links right here. So you will want to check that out if you want to see the recordings. All right. I hope that all sounds good. Okay, great. Let's get down to some calculus then. So I would like to talk a little bit of review. Like I said, I am kind of imagining that you all just finished the Calc 1 last semester, and if so, then you probably don't need any review. I mean, we're kind of like just continuing directly from there, but just in case, I thought I would do some kind of real quick review of what I expect you to know already, and then we'll go from there. So actually, you can follow. Oh, one thing I forgot to say about this list here. Each day we're going to do like the next thing on the list. That's typically so. The first two topics on the list are I have labeled as review topics: simple derivatives and antiderivatives, and then the u-substitution. These are things that I think you did already in the Calc 1, but I just want to make sure that everybody is feeling good about them. This list, I said on the bottom here, bring this to your in-class exams and don't write other stuff on it. That's on these sort of catch-up exams, you're going to see lots of questions and you only have to do the ones you don't already have credit on. So I intend for you to like keep track on your list of what your points are and then bring this to the test so that you know which ones you gotta do and not do. And I'm gonna say like there's no notes no notes allowed during the test. So don't write your secret formulas on the paper, right? When you bring it to the test, I don't want to see other nonsense on the paper. All right, anyway, let's talk about simple derivatives and integrals. That's the first topic there, simple derivatives and antiderivatives. So the very basic thing you need to know about the derivative is this. This is called the power rule, and I hope everybody knows this. If you remember anything about the derivative, it's probably this. Derivative of something to some power. You bring the power down to the front, and then you decrease the power by 1. That's the derivative. And there's a similar antiderivative formula, also known as the integral, where you do the opposite, because the antiderivative is supposed to be the opposite of the derivative. And the first one says multiply by n and then decrease n by 1. This, you do it the other way around. That is, instead of multiplying, you divide, and instead of subtracting 1, you add 1. It looks like this. 1 over n plus 1, x to the n plus 1. And then you got to put the plus c. This is just a thing about the antiderivative. You always have to add. They call it the constant of integration. It is annoying. Sometimes you forget the plus c. It usually doesn't matter that much, although it is important in some cases. All right, so these are the very basic derivative and integral sort of rules here. So for example, if I say, what is derivative of x to the 4? Somebody want to shout it out? What do you say?
4x to the third.
4x to the third, excellent. I hope you will feel free to holla at me, as they say, if you have questions or whatever. That's not a sexual thing, is it? No, all right. Sometimes I feel like, is it? I don't know. Sometimes I hear the young folks talking to each other and I don't fully understand the nuance. Please let me know if I get the nuance wrong. Yeah, this is, feel free to interrupt if you have questions or whatever. Shout them out. Okay, that's the derivative, or you could do something a little fancier. How about derivative of 8 root x? Anybody remember, how do you handle the root? I didn't actually say anything about square roots, but it fits into those nicely. Anyone remember how to work with that? Yeah?
It turns to a 1/2.
Yeah, the square root is the same as a 1/2 power. So this, before doing the derivative, this is the same as 8x to the 1/2. I wrote the dx again because I didn't actually do the derivative. All I did here, I just wrote root x as x to the 1/2 instead. And now I can do the derivative here using the power rule. The 1/2 comes down in front. It has to multiply onto the 8, so it's really like 8 times 1/2 x. And then the new power, I subtract 1. It's going to be 1/2 minus 1, which is negative 1/2. So it's like that. This is the answer. Now, if you like, you can simplify. I usually don't really care about simplifying things, but 8 times 1/2 is 4, right? So this, if you like, is like that. Some people don't like writing negative exponents. I am perfectly fine writing negative exponents. But this, if you prefer, you could write this as 4 times 1 over x to the 1/2, 4 times 1 over root x, or something like that. There are many ways to write it. Generally speaking, I don't really care how you write or simplify your answers as long as you're doing the calculus part correct. All right. In my opinion, like, this is a calculus course. This is not a class about, like, do you know how to simplify fractions? So, like, I hope you do all know how to simplify fractions. And every so often, you're going to have to simplify fractions. But I don't really care when you're writing your answers if you simplify the fractions or whatever. All right. And how about, I got an integral here. Integral 3x to the 5 plus 4 dx. Yeah, integrals always have a dx in them. Anybody want to shout this out? Here I have 2 things added together, but you just, when you have addition inside integral, I hope you remember, you just do each part on its own. Someone want to tell me the first one? I got the 3. What do I do with x to the 5? It's this rule here. So if the 3 just kind of stays the way it is, but here I have x to the 5, it turns into this. So these numbers here will become a 6. You increase by 1, yeah?
1/2 x to the 6 plus 4x plus 6.
Yeah. So I was going to say 3 times 1 over 6 x to the 6. This is why he said 1/2 x to the 6, because he simplified the fractions, which is fine. And then what about the 4? This is something I didn't mention specifically, but you just have to remember. If you have just a constant and you take the integral, what happens? It's that constant times x. So this becomes plus 4x. The rule for constants is the derivative of a constant is always 0. The integral of a constant is always that same constant times x, or times whatever the variable is. All right? And then the last thing he said was plus c, which is, you always got to put that after you do an integral of something. Right? Any questions about that one? I hope that everybody feels good about these. Maybe you forgot how to do them over the break, but these are easy ones. These are review ones. All right? I also will expect you to know things like the, rules, like the product, the quotient, the chain rule. These come up all the time in Calc 1 because they are rules for the derivative. We're actually not going to use these all that often. They are still important, and I will expect you to know how to do them, but we're not going to do these every day because mostly we'll be talking about the integral rather than the derivative. The product rule, the quotient rule, and the chain rule, you should know them. And you should also know things about the trig functions. Also know values and properties of sine and cosine and tangent. Now, there are lots of obscure formulas about these that I would not expect you to remember, but in terms of like properties of these things, you should know the standard kind of unit circle values, like, what is sine of pi over 3. And by the way, we are almost always going to be using radians, not often using degrees. Pi over 3 is the same as 60 degrees, though, if you prefer. So this is something that either you just memorize or you remember. You have to memorize at some level these things, and I don't really care how you think about these. When I see this, the way I think of it is this is 60 degrees, which looks like that, and I have memorized the dimensions of a 30, 60, 90 triangle. I hope this sounds familiar. They go 1, 2, and root 3. And so the sine of this is the opposite over the hypotenuse, which is root 3 over 2. So this is how I would figure that out. Maybe you have this. This is because like I'm actually not very big on memorizing things. Some people just like memorize all of these values, and that's, if you can do it, that's totally fine with me. But I am more likely to think it through using these triangles. This is something that you may want to review if you've forgotten how to do this sort of a thing. The cosine of pi over 3, or how about what's the cosine of pi over 6? Pi over 6 is this angle over here, 30 degrees, and the cosine of that would be the adjacent over the hypotenuse, which from this side, the adjacent is here and the hypotenuse is here. So this is also root 3 over 2, etc. You should know values, pi over 3, pi over 6, and pi over 4. That's 45 degrees. And then you should also know values for 0 and multiples of pi. So sine and cosine of things like 2 pi, pi over 2. I think you all know what I'm talking about, right? You should also know about, so in terms of, like, these are values that I was referring to. What about various properties? Really, I will only ever expect you to know this. The tan is sine over cosine. We use this all the time. And also this, sine squared plus cosine squared equals 1. All right, these are the important sort of formulas that we're going to use all the time. There are some other weirder trigonometric formulas that we're going to use from time to time, but I wouldn't expect you to have them memorized apart from these ones. All right. You'll see on the homework what sorts of things I expect you to be able to do with the trigonometry. Okay, and you should know about derivatives and integrals. Again, there are lots of obscure formulas that I would not expect you to remember. This I would expect you to remember. The derivative of sine is cosine, and the derivative of cosine is negative sine. These we use all the time. There's a derivative of tan is secant squared, which some people, that comes up every so often. I don't really expect you to have memorized all those other ones. Although maybe I should say I do expect you to know what the definitions of secant, cosecant, and cotan, right? The secant is 1 over cosine, the cosecant is 1 over sine, and the cotangent is 1 over tangent. I hope everybody remembers those things. All right. Okay, anyway, those are the derivatives of sine and cosine. There are also formulas for derivatives of the other ones, but they are weirder, and I don't really care if you have them memorized or not. And then we have integral formulas. Integral of cosine is sine x plus c, and the integral of sine x is negative cosine x plus c. Unfortunately, these are easy to get it twisted. You have to just keep straight where the minus signs go, and it is confusing from time to time. But all right, those are the basic formulas from trigonometry that I expect you to know. All right, great. Okay, 2 more simple examples, and then I have some for you all to try. I like to do this, at least once every time we meet. I'll give you some problems to work on, and I sort of walk around and see how you're doing. I'm not trying to grade you or anything like that. This is just to make sure that everybody is understanding and following along. Okay. One last thing that I didn't mention yet, and that is what about a definite integral? This is what we call a definite integral. That means it has the little numbers at the top and the bottom. This represents the area under the curve of something. It represents that function, the area under the curve from x equals 3 up to x equals 8. I hope you remember that. But anyway, how do you handle the little 3 and little 8? It's not difficult. You just have to remember how to do it. First of all, you do the antiderivative of the stuff on the inside using the power rule. So x squared will become 1/3 x cubed. 7 times x. I can just leave the 7. The coefficient stays like it is. This x I think of as like a x to the 1. And then I increase the 1 to a 2 and divide by the 2. So this is 7 1/2 x squared. That's what the x to the 1 became. And then the 2 on the end is just a constant 2, which when I do the integral becomes 2x. All right. So that's the antiderivative. How we handle the 8 and the 3, this is, people write this in different ways, but this is the way that I'm always going to write it. You put this bar over there with the 8 and the 3. And the meaning of the bar is, in the next step, I'm going to plug in the 8 first for x everywhere, and then subtract, and then plug in the 3 for x everywhere. I hope this sounds familiar. So this means 1/3, I'm plugging in 8, and it goes in for x everywhere. So there, I plugged in 8 everywhere. And then you go minus, and write everything again, plugging in 3 everywhere. And you basically always need to put big parentheses here, because that minus right there needs to distribute across the rest of it. But now I'm going to go through and write 3 everywhere. So 1/3 times 3 cubed minus 7 times 1/2 times 3 squared plus 2 times 3, like that. And this is my answer. In the general theme of, I don't care how you simplify stuff, I would expect you to just leave it like that. If you really want to, you can type this into your calculator. I don't care what the answer is, actually. You could try and add the fractions. This would be a nightmare to do. I'm not into that, all right? My concern is that you know how to do the calculus, like I said. I don't actually really care if you are able to type this number into your calculator. I mean, I hope that you are able, if you really had to, type this number into your calculator. I don't need to see it, though. All right? Great. I got one more. One more definite integral. How about integral 0 to pi over 2 sine of x dx? All right. Remember, like I said, this represents the area under the curve. I hope you remember what the graph of sine of x looks like. It looks like this, right? It's got these sort of bumpity bumps. And pi over 2, so this is pi over 2. So this answer, whatever it is, represents the area of that little half of the bump, right? Anyway, let's see if we can work it out. First of all, you have to do the antiderivative of sine x. Anybody remember? I wrote it a few moments ago. What's the function going to turn into? Yeah? Negative cosine x. Great. And then I got to plug in. So I put my bar, pi over 2 and 0. And now we plug them in. So I go minus cosine pi over 2, subtract negative cosine 0, right? You plug the top value in, and then you subtract, and you plug the bottom value in. And now these, I would expect you to know these values. These can come from memorizing things on the unit circle, or actually when I learned to do this in my youth, I just remember the graph of sine and cosine, right? This is sine, that's pi. Cosine looks like this, or that's pi. This is pi over 2, right? If you can remember these two pictures, I can see right away cosine pi over 2 is 0, because this graph goes through 0 there. And cosine of 0 is at the beginning, it's 1. So this here is negative, I'm doing cosine pi over 2 is 0, and then minus 1. All right, this is 1. I just said I don't care about simplifying, but I think it's kind of cute to notice that that area right there is 1. Isn't that cute? Don't your friends ask you at lunch, oh, you know calculus, right? What's the area of one of those bumps in the sine and cosine? The answer is actually, this whole bump has area 2. This half of it is area 1. Tell your friends. Tell your grandmas. All right, that's where all that money they're spending on you being here. Okay, great. I got some for you all to try. These ones will be a little tricky, maybe. I don't know. Requiring some tricks that I haven't quite discussed yet, but I hope that you remember. That one, and I got another. My advice to you for both of these is write stuff using negative exponents. This is my hint. This is a very basic trick that we do all the time when trying to do integrals. I hope you remember a little something about how you would use negative exponents to do each of these. All right, see what you think. Feel free to chat with your friends about it. I'm going to walk around and see how you're doing. I'm not trying to grade you, like I said. Just make sure that everybody is following along okay. Maybe the second one is easier. I don't know. When you see something in the bottom like this x squared, you can write as x to the minus 2. Bring it outside of the denominator. Anywhere? Yeah. There should be like parentheses here. And then you can distribute this, and it'll look like a normal. Yeah.
I took it last year, so I took it my senior year of high school. So what's your big stupid from minors?
I'm just going to go with my dad.
I think when you distribute it, you should add any That's good?
It should be right.
So that's
Yeah. Okay.
And then do the integrals.
Yep. Okay. I wasn't sure if you could do that. If I was making this work.
So this, I would suggest, this x squared in the bottom, same as x to the negative 2. So you can change it to that stuff times x to the minus 2. So you have to do some fancy business with that.
It's all true. You got future in the
It looks like you're trying to just do the top and also do the bottom. You can't do that in a fraction. So you should rewrite using a negative exponent. This x squared will also you can write instead as x minus 2. I see people, some people getting nowhere and some people doing just fine. Let's talk about these. I know not everybody is done yet, and that's all right. The first one, when I say write stuff using negative exponents, what I mean is this right here, for example, instead of dividing x squared, that is the same as this multiplying x to the minus 2. So this is a standard trick, which is going to come up every so often. If you have power of x in the denominator, that is the same as multiplying that same power of x, but make it negative, right? Because x, what x to the minus 2 right here, what this means is 1 over x to the 2, which is what it said originally, all right? Now from here, what can we do? One thing, let me just say, I saw several people just from here, they just did the integral on top and then also did the integral on the bottom. This is not allowed. You have a quotient here. You have to handle it in some fancy way. Now for the derivative, you have a quotient rule. There is no such thing as a quotient rule for the integral. You just have to somehow deal with this and make it into something that's not a quotient. And that's what I did here. Now we still have a product here, but that can be dealt with by distributing. So I'm going to distribute this guy like so, right? And when we multiply, we should be adding the exponents. So it's going to be x squared times x to the negative 2. Those add to give me x to the 0, which is just 1. And then minus 7x to the minus 2. Right? This is the end of sort of the tricks which are involved, right? All of this was just trying to write this into a format which is convenient to do the integral. And now I can do my usual integration tricks on this. So 1 being a constant, when I take the integral, it becomes 1 times x. And then this guy, I do the thing with the exponent. The minus 7 in front stays like it is. And then the exponent, negative 2, I increase by 1, it becomes negative 1. And then I divide and write x to the negative 1. So it's 1 over minus 1, x to the minus 1. And then I would ordinarily plus c, but I have the numbers. So it's 7 and 3. All right. Doing all right? Add them. All right. There's a lot of ones here. This is really just x plus 7x to the negative 1, right? If you were to simplify. But anyway, now I'm going to plug the numbers in. The hard part is over. Now it's just a matter of writing the answer. Plug the numbers in. The 7 goes in. It's just 7 minus 7 times. That's a negative 1. Can I write all of this as like a plus 7 and a plus 1, right? It's plus 7 times 1 to the negative 1. And then subtract, plug in 3 everywhere. 3 plus 7 times 3 to the minus 1. This is my answer. All right? Any thoughts about the first one there? Are you guys talking about the other one?
Yeah.
We can all hear you. We're almost there. We good with this one? All right, let's talk about the other one. It is 1 over 8x to the 4 from 7 to 4 dx. All right? This one, maybe this is easier. I don't know. You do a similar trick. When I see a power of x in the bottom, you raise it up, but make the exponent negative. All right? So instead of 1 over 8x to the 4, here's a little trick. As I was walking around, I saw some people mess this up. This is the same as 1/8 times x to the minus 4. All right? I bring the x out of the denominator and make the exponent negative. All right. Here's a little check yourself. It's not 8x to the minus 4. These are different, right? 1/8 x to the minus 4 is not the same as 8 times x to the minus 4, right? Because 8 as a coefficient, 8 and 1/8 are not the same. So those are two different things. This is the correct one. Because 8 is on the bottom, I moved the x out of the denominator, but I didn't move the 8 out of the denominator, all right? It's not 8x to the minus 4. It's 1/8 x to the minus 4, all right? But anyway, from there, we can do the rest of the integral as usual. So I have 1/8 stays like it is, and then I do the power thing with x to the minus 4. We increase the power by 1. Can anyone say what's the rest of this going to look like? I'm going to increase the power by 1 and then divide by the new power. I think I heard somebody whisper 1 over minus 3 x to the minus 3. I agree with the whisper. It was -4, the exponent. I increased by 1. -4 plus 1 is -3. And then I go 1 over -3 x to the minus 3. Great. So the hard part is over, but now we just have to plug the two numbers in. If you want to simplify the fractions, you would multiply 1 over -24, I guess is what that is, right? But I don't really care about that. It's 7 to the minus 3 minus 1 over -24, 4 to the minus 3. There you go. All right. This is what I'm talking about. Any thoughts about those ones? I hope that these looked okay. I mean, these are slightly obscure tricks, so if you don't quite remember all of this, that's all right, although you best remember it soon enough. All right. Here ends what I wanted to talk about as far as like simple derivatives and antiderivatives. I hope that even if you don't remember how to do all this at this very moment, I hope this at least looks familiar to you all, and you'll have it together. So I will. This will be part of the first homework assignment due next week, just to give you an idea of like what is the stuff that I expect that you already know how to do from this. All right. Great. We got like 15 minutes left. I think we can start talking about the u-substitution, which is the next topic on the big list. This is also something that I expect you already know about, but it's good to review because the u-substitution is super important, and it's kind of confusing in my opinion. I don't know if you feel the same way. So let's talk about the u-substitution. This is fundamentally just a trick for integrals. All right, you do the u-substitution when you have complicated things to integrate. The ones that we just did, you didn't need to do the u-substitution because they were like somehow easy ones. I don't know if they were easy ones, but they did not require the u-substitution, all right? Sometimes you do need to do the u-substitution. It's a trick for doing integrals. For example, the idea here, this is the basic idea of the u-substitution. If I have some kind of complicated thing like this, this actually is a great example to use the u-substitution in. What makes this hard to do is the 6th power there. Now you might say, can I just like do the integral inside of this and leave the 6 like it is? The answer is no, it doesn't work that way. Like the 6 really does matter here. You might say, oh, can I increase the 6 to a 7 and do some business like that? Well, the stuff in the inside also matters. So you have to actually do something kind of special here. But the basic idea is this is just basically like something to the 6, right? So the answer, that's just like a scribble. It's just like some stuff to the 6th power. So the answer should be like 1/7 some stuff to the 7, right? If I just have some stuff to the 6, this is the basic rule that you would do in this case if you were doing the integral. Now the question is, okay, it is basically that, but what about the 5x plus 2? Like, what are you supposed to do with that? Do you just leave it the same on the inside? Does it have some effect on anything? The answer is yes, it does have an effect on anything, and you have to know how to deal with the inside. So let me just say the inside matters, and will change the answer a little bit. And the u-substitution is basically just like the details of exactly how to handle this kind of a thing. So the inside there does matter, and it will change the answer a bit. Let's just talk about how to do this. So if you were trying to do that one, I'll try and write exactly the same thing again. The way you write this out is, first of all, and this is one thing that immediately makes the u-substitution harder, you decide for yourself that thing on the inside, I'm going to call that u. So I'm going to say, let u be 5x plus 2. Why did I do that? Why did I choose that to be the u? It's because I know when I do the u-substitution, the u should equal the thing on the inside. So the u is, I will say, usually the stuff on the inside. Now, there are some examples that we're going to do where it doesn't really look like there's specifically stuff on the inside. In this example, it's very clear what's inside and what's on the outside, right? This can be sometimes a difficult step to figure out. But anyway, usually you decide u to be the stuff on the inside, but it's up to you to choose what the u is. Why didn't I choose the u to be the 6th part? It's because I know how to do the u-substitution, and usually the u being the thing on the inside is what's going to work. All right. So anyway, u is usually the stuff on the inside. Then you take the derivative of u to find the du. And I'm going to write it this way. Du is, well, maybe, can I just write the u again? So u is 5x plus 2. The du is the derivative of that. Derivative of 5x plus 2 is just 5. X to the 1 will go away when you take the derivative. And then you put dx there. So du always includes the dx, all right? It's the derivative. That's why I got 5 as the answer, because it's the derivative of 5x plus 2. And you always just insert a dx there, all right? Okay, almost ready here. I am going to, one more thing here. Now there are actually a few different ways that people write u-substitutions. If you learn to write it in a slightly different way, that's totally fine with me. Right here, I am going to solve for the dx, or another way to say it, I'm going to divide 5. It now says 1/5 du equals dx. All right, I just took this thing and put the 5 on the other side for reasons which will become apparent in a moment. All right, I put the 5 on the other side. 1/5 du equals dx. And now we substitute. So where I started was 5x plus 2 to the 6 dx. And I'm going to plug in everything here. I want to change it all to u's and du's and have no x's left over. So 5x plus 2 is u. So this becomes u in there to the 6 dx, right? First, I plugged in for u. U is 5x plus 2. That's right here. 5x plus 2 is u. What about dx? Remember I said I don't want to see any x's in here at all. I want just u's and du's. Dx, you can see also up here. Dx is 1/5 du. So this whole thing is integral u to the 6 times 1/5 du. This is the u substitution. So the goal here is we need to write everything using only u and du, no x and dx, all right? So we replace the 5x plus 2 with a u, and I replace the dx with a 1/5 du, all right? And now this is an integral that we can do. We have this kind of like extra constant in here, I hope you remember there's a rule. If you have a constant multiple inside an integral, you can just take it all the way out of the integral. So continuing from here, I am going to take the constant multiple out of the integral. And now this is an easy integration to do. It's just the integral of u to the 6, just the power of 6. The integral is going to be 1/7 u to the 7, because this is just a power of 6. So 1/5, 1/7 u to the 7, and this is where I put the plus c. All right. That right there was the key sort of step in which I actually did the integral. U to the 6 became 1/7 u to the 7. And you may notice I've been writing the integral sign every time. Every step here I wrote the integral sign. I hope you were doing that too. Every so often I meet integral sign haters. People are just like, I don't really write that thing. You should write that thing. Don't be an integral sign hater. It matters that I wrote it, all of these steps, but then I didn't write it here. This is because all of these steps I was supposed to be doing the antiderivative, but instead I was just like resimplifying stuff. Here's the point at which I actually did the antiderivative, in that step right there. And that's why I didn't write the integral sign anymore. All right, this is almost done. There's always one last step in the u-substitution, and that is write the answer using the original variable, the OG variable, which was x. All right, I don't want to write my answer in terms of u when I started with an integral in terms of x. And this is always easy to do, but you have to just see the u here and replace it with whatever it is. U is 5x plus 2. So I plug back in, this is 1/5, 1/7, and then here, 5x plus 2, because that's what u is. Like so. And this is my final answer. All right. This is the u-substitution. It is complicated. I mean, it's a lot more complicated than the simpler tricks that we were just doing on the other ones, in my opinion. All right. I got one more example that'll do us for today, I think, and then we'll do a few more of these next time. Any questions, though? First of all, this is kind of a process. You have to, first of all, look at it and figure out what part you want to be the u. I chose the inside of these parentheses to be the u. And then you find the du. Then you divide out by a constant. Sometimes this step is not necessary. Then you do all of your substitutions to make it all u's. And then you do the integral, and then put the original variable back in at the very end. Let's try one more, and then we'll do several more next time. How about this? 2x, x squared plus 10 to the 10. Oh, yes. Oops. All right. We are going to do the u substitution also, surprising no one. The first step is to choose for yourself what should the u be. Generally speaking, you want to choose something which is on the inside of something. Anybody see a likely candidate here? A piece of this which is on the inside of something or other. Yeah?
X squared plus 10.
X squared plus 10, I think that's the only thing that strikes me as being inside of something else. This is how the u substitution always works. You have an inside part and then the rest of it. All right? So that's the u. Great. I should write, what is the du? The du is always the derivative of u. Can anyone say what's the du going to be? 2x. Yeah. Just 2x, right? That's the derivative of u. And like I said before, the du always includes the dx. All right? 2x and dx. Okay? I think we can start trying to substitute. So my original thing here, I'm going to try to plug stuff in so that everything is in terms of u's and du's, no x's anymore. All right? I would start, now if you know what you're doing, you can probably do all of this in one step. I'm going to do it in a few steps though. I'll leave the 2x like it is. First, I'm just going to put the u where it goes on the inside there, right? U to the 10. U is the inside of that stuff, so I just write it as u, all right? Now, what is left over? 2x and dx. Maybe I'll write the u first, just because the u, I feel good about u to the 10. All the rest of it is 2x dx. And now we have to somehow write this stuff using u's, not using x's anymore. But we're kind of get lucky in this case. 2x dx, I see that right here. That is equal to du. So this part is just du, right? I don't want to write that in there. So it says u to the 10 du. That's it. All right. Here we actually didn't have to like factor out a constant or anything like that, which we did in the previous one. Any thoughts about? I'm not done yet, but I hope everybody's feeling good so far. All right. You have the u part, which was on the inside, and then there was like other stuff left over, but that other stuff in this example ended up being equal to du. All right. Now we do the integral. U to the 10, the integral, you would increase the power by 1 and divide by the power. So the power becomes 11, and I get 1 over 11, u to the 11. Don't write the integral sign anymore because that's the step in which I actually did the integral by increasing the powers and whatever. All right, almost done. One last step. Anyone remember the last step? This is always easy. You just remember to do it. Yeah, plug the x's back in instead of u. So u here, I want to see the answer in terms of x, not u. And you just have to remember, at the very beginning we said u is x squared plus 10. So I plugged that in. So it's 1 over 11, x squared plus 10 to the 11 plus c. That's it. All right. One thing can I say? I said this was going to be it. About the u-substitution, this is actually true of any integral that you do. You can always check your answer. Can we just say, how do we check it? Check it. Anybody remember how to check it? This is supposed to be the antiderivative of what I started with over here. You can check that this is correct by taking the derivative of this, and if it's all right, you should end up with that as your answer. All right, so you can check it by take the derivative of the answer, and you should get the original formula. Can we do that? So if I take the derivative of 1 over 11, x squared plus 10 to the 11, plus c, right? The derivative will kill the c. The c is just a constant added onto the end, so that's going to go away. But the rest of it, actually, this is a nice opportunity to review the chain rule. What we have here is stuff inside of another thing, and I hope you all remember how to do the chain rule. You do the derivative of the outside, leaving the same thing on the inside, and then you multiply times the derivative of the inside. So what this looks like is 1 over 11 will be a coefficient, and now x squared plus 10 to the 11. I do the derivative on the outside, which means the 11 comes in the front. I write the same stuff inside, and then decrease the power by 1. It's like that. And then the chain rule says times the derivative of the inside. That's the chain rule part. All right. What is this? The 11ths will cancel on the front. 11 times 1 over 11. And so this is just 2x times x squared plus 10 to the 10. And this actually is equal to what we started with inside the integral, right? Story checks out. All right. I think that'll do. See you all tomorrow. Let me know if you got any questions about anything.